Hey everyone, and welcome to this explainer. Okay, let's jump right in, because today we are looking at an absolutely massive cypherpunk-style disruption that completely shook the tech world in 2026. We are going to unpack exactly how generative AI underwent this seismic shift, and how Chinese models transformed, practically overnight, from being seen as just, cheap alternatives into absolute top-tier enterprise essentials. It's a fascinating story about economics, geopolitical constraints, and just brilliant software engineering. So let's get into it.
To really understand this, you just have to look at the sheer scale of the disruption. 28 cents versus $5. That is the staggering price-to-performance gap that totally defined the 2026 market. On one side, we have DeepSeek unifying its pricing at a ridiculously low 28 cents per million input tokens. And then on the other side, OpenAI's comparable flagship rates are sitting right around $5. I mean, that is a 90% discount. The headline here is just raw cost disruption. For the exact same volume of AI intelligence, the price floor didn't just drop, it completely fell out.
And the real-world impact of a price drop like that is what analysts are calling the Lindy effect. This is named after the AI startup Lindy. When the crazy economics of running large language models started coming under real scrutiny, Lindy just migrated its entire traffic away from Western models and straight over to DeepSeek. And the result? Their chief executive reported that operating costs literally crashed to the ground. We're talking about saving millions of dollars in just a matter of months. So this wasn't just some minor budget trim. It was a fundamental shift in how businesses even think about deploying generative AI. If you look across the broader market API budget tiers, you'll see DeepSeek and Z.ai absolutely dominating that tier of under 50 cents per million tokens. For companies running high-volume production environments, say you're doing a standardized workload of about 30 million input and output tokens a month, switching from a US frontier model to something like DeepSeek V4 Pro or Z.ai's GLM-5.2, that can reduce your monthly bill by 17 to 27 times. It is literally a buyer's paradise right now for developers. But I know what you're probably thinking. Cheap means inferior, right? Well, independent evaluations actually prove that myth entirely wrong. When you look at standard software engineering tasks, things like bug fixing and refactoring, DeepSeek Chat achieves a perfect 10 out of 10 score. They are hitting the exact same high performance as the most expensive models on the market, but at the absolute lowest cost. For standard coding tasks, intelligence has basically reached total parity. Now, we do need to look at the full picture here. A report from NIST, that's the National Institute of Standards and Technology, shows that US labs definitely haven't been sitting still. Highly optimized US models, like OpenAI's GPT-5 Mini, are still incredibly competitive. In fact, when NIST ran end-to-end expense evaluations, they found that for completing specific tasks, GPT-5 Mini could actually cost about 35% less than DeepSeek V3.1, all while achieving similar performance. So make no mistake, the competition at this hyper-efficient tier is absolutely fierce. But the really crucial point for us today is that the overall market pricing ceiling has irreversibly collapsed. The days of paying massive premium rates for standard AI tasks, those are completely over. Which brings us to a really fascinating geopolitical detective story. How exactly did these extreme cost reductions happen? Especially when you consider that US export controls on those high-end NVIDIA chips were at their absolute tightest. Chinese firms simply didn't have unconstrained access to the hardware that Western labs were using to train their massive models. So, how do you build a perfect 10 out of 10 model on a tight hardware budget? Well, over the past decade, the US strategy was basically to maintain AI leadership by controlling the technological choke points, specifically advanced semiconductors. The 2022 export controls directly targeted the compute infrastructure underlying frontier AI, and by 2023 and 2024, those rules tightened even further. But research from Archive shows that this strategy actually had a massive unintended consequence. It kind of backfired. By making high-end chips so scarce, it forced Chinese developers to radically pivot. They had to shift their entire focus toward inference optimization and edge deployment, which basically means figuring out how to run highly complex AI locally on much weaker everyday devices. And this situation birthed two radically different engineering philosophies. On one side, you have the Western approach, brute force compute. Just throw an absolute mountain of expensive GPUs at a problem until it becomes smart. But on the other side, you have the Chinese necessity, closeness to the metal. Because they lacked the absolute best chips, they literally had to master extreme software and architectural efficiency just to squeeze every single drop of performance out of export-compliant hardware. So what does closeness to the metal actually look like in practice? Let's look at the specs for a model like Z.ai's GLM-5.2. They use a highly complex mixture of experts architecture. The model has a massive 744 billion total parameters, but here's the magic trick. Only 40 billion parameters actually activate on any given forward pass. Combine that with parameter-efficient fine-tuning, or PFT, which basically means teaching a model new tricks without rebuilding the whole thing from scratch, and you get models running incredibly complex logic on heavily restricted hardware. It is pure innovation born entirely out of constraint. Okay, I want to gracefully transition the narrative for a second here, because to truly understand the power of China's open-weight strategy, we actually need to step outside of computer science and look at, well, ecology, specifically the Sebasticook River in Maine. Bear with me, it's because biological ecosystems thrive on abundant foundational resources. And as you'll see, the dynamics of a biological ecosystem perfectly mirror the dynamics of a digital one. See, every spring, about 5.7 million river herring migrate up the Sebasticook. This massive pulse of fish provides a fundamental nutrient layer that supports the entire local ecosystem, from the bald eagles all the way to the local economy. Now, draw a parallel to the digital world. Since the release of highly efficient models like DeepSeek R1, global developer downloads have surged by nearly 1,000%. Just like those millions of herring feed the river, these highly efficient, freely available open-weight models are acting as the foundational nutrient layer, fueling the entire global OpenAI stock. Which brings us to this really powerful quote from the archive research analyzing this whole shift. Under geopolitical constraint, openness can serve not only as a direction for innovation, but also as resilience infrastructure. By releasing these highly optimized open-weight models, China isn't just competing on price anymore. They are positioning themselves as the foundational resilience infrastructure for the entire globe. They're handing out the essential building blocks for anyone who wants to develop AI locally, totally outside of foreign-controlled platforms. And that leads directly to what analysts are now calling the atomic diplomacy of AI. Much like exporting nuclear technology builds deep, long-term international ties, these open AI models like Quen and GLM are quickly becoming the default standard for developers around the world. If you're a developer in the global south, or honestly anywhere, wanting to avoid dependence on Western-controlled closed-source ecosystems, these highly efficient, locally adaptable Chinese models are incredibly attractive. They are entrenching a completely new standard. So the crucial point for enterprise architects today basically boils down to one single question. Analysts estimate that China's leading AI models currently trail the absolute bleeding-edge U.S. frontier systems by only about 6 to 9 months. But depending on your setup, those U.S. models can cost up to 27 or even 53 times more. You really have to ask yourself, is a 6 to 9 month performance lead actually worth a 53x higher cost? Especially when the foundational open layer is already this capable. For most standard business applications, the answer is increasingly becoming a resounding no. Which leaves us with this final, thought-provoking question to end our explainer today. We've seen how strict constraints forced incredible efficiency, driving prices to the absolute floor and pushing open-source models out to the entire world like a shared foundational resource. So, what happens when the global standard for digital resilience, the very foundation developers everywhere rely on to build a future, is no longer built in the West? It is a biological scale ecosystem shift, and it is reshaping the future of technology as we know it. Thanks so much for joining me on this explainer today, and as always, keep questioning the data.